class. So I told you regarding the shells and orbitals and also the subshells. Okay. So let me just revise and then we are going to start electronic configuration. Okay. Uh, I was telling you that let's suppose first of all you have atom. First of all you have atom. Listen very carefully. This is very important concept. Okay. First of all we have atom. Then in an atom we have different shells. Then in an atom we have different shells. Okay. And then let's suppose atom is just like a building. Just imagine this is just like a building. Okay. This is building. And building is your atom. This building has different floors. Just imagine this building has different floors. Okay. So in an atom you will see the shells. So shells are just like floors. Okay. And then you have subshells. You have subshells. Subshells are just like a room. And then you have orbitals. Then you have orbitals. Orbitals are just like beds. Orbitals are just like beds. Okay. So then I told you that we have different shells. We have different shells, 1, 2, 3, 4, 5, so on. Okay. And then I told you that we have different subshells that are S, P, D, F. And then in S, P, D, F, we have, I told you that in S orbital, in S subshell, we have only one box for S. We have 3 boxes for P. We have 5 boxes for D. And we have 7 boxes for F. Okay, so I can tell you that S has only 1 orbital, P has 3 orbitals, D has 5 orbitals, and F has 7 orbitals. I have summarized the last class. This is very important concept. Okay, I have summarized the last class. And then let's see that we have, first of all, I'm going to make a table. It would help you a lot. Okay, I'm going to make a table. The first one is we have number of shells. And then we have number of subshells. And then we have type of subshells. And then we have number of orbitals. Okay. Right. Okay. Let's suppose we have one shell, the first shell, in which we have only one subshell, and the type of subshell is S, and in that orbital you have, like in S subshell you have one orbital. Okay. Then we have the second shell. In the second shell you have 2 subshells, and the type of two subshells are S and P. Okay, and then S has one orbital and P has three orbitals, so the total are four orbitals. Okay, then we have the third shell. Third shell means that the type of subshells are three, so the three means S, P and D. S has only one orbital, P has three orbital, and the D has five orbitals, so the total is 9. Then we have the fourth shell, in which you have four number of subshells, and the four number of subshells means this. Okay, and S subshell is having one orbital, then P is having three, then D is having five, and the F is having seven, so the total is 16. So the total is 16 and so on. That's it, because we would be completing electronic configuration for first 30 elements. So that's more than enough for those elements. Okay, that's more than enough for those elements. So hopefully it made your concept more crystal clear, that what is the difference between the shell and subshell and the number of orbitals. Okay, so it would help you a lot. So, and then
So we need to remember the number of orbitals.
yes, exactly.
Okay.
Okay, sometime in MCQs, so they would be giving you, you know, more tricky questions, so it would be helping you in that MCQ. Okay, so basically we are going to do you can say uh, electronic configuration. Okay, so we are going to start electronic configuration. Electronic configuration. So electronic configuration means that arrangement of electrons, arrangement of electrons in different, you can say, subshells. Electronic configuration in different subshells. But the thing is that how would I know that? How would I know that which subshell is having a lower energy and which subshell is having a high energy? This is the main question that we need to know. This is the main information that we need to know, which subshell is having the lowest energy and which subshell is having the highest energy. Remember, so basically, we have to arrange electrons in different subshells, or you can say in different orbitals. So here are some rules. Here are some rules. Rules, rules for rules for electronic configuration. Rules for electronic configuration. Rule number one is Aufbau principle. Rule number one is Aufbau principle. Okay, Aufbau principle. This is not the name of the scientist. This is a Greek word which means that the building up. Which means that the building up. What this rule says, according to this rule, we say that uh, shell shell or orbital shell or orbital with the lowest energy with the lowest energy is filled first. Is filled first. Okay, with the lowest energy is filled first. Like, I mean to say that lowest energy means that the orbital which is closest to the nucleus. Closest to the nucleus. Let's suppose I have two orbitals, 1s and then 2s. So this is closer to the nucleus. And this orbital is far away from the nucleus. Ultimately, I can say that this is having higher energy and this is having lower energy. So you would be filling this orbital first. Fill it first. Okay, fill it first. Fill it later. Okay, because this is having the higher energy. Basically, this is the rule. This rule says that you have to fill those orbitals which are having the lowest energy. So how can you decide? How can you decide which one is having the lowest energy and which one is having the highest energy? So you can see over here that 1, 2, 3, 4, 5, 6, 7. 2, 3, 4, 5, 6, 7. 3, 4, 5, 6, 7. 4, 5, 6, 7. S, 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 S. Then P, 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 P. Then D, 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 D. Then F, F, F. Okay, then afterwards I would be just drawing an arrow just like that. 1s, then 2s, then the arrow is on 2p, then the arrow is on 3s, then the arrow is on 3d. Okay, then 3d, then 4, then 3p, then 4s, then 4d, then 4p, then 5s, then 4f, and then so on, and then so on, and then so on. So then let's suppose if I ask on which orbital is the first arrow, you will say sir on 1s. Then I would ask, then afterwards you would say 2s, then 2p, then 3s, then 3p, then 4s, then 3d. Okay, then 3d, then 4p, then 5s, then so on. So it means that this is the orbital which is having the lowest energy. This is the orbital which is having the lowest energy, because this is the orbital which is connected to, like, closest to the nucleus. That's why it's having a lowest energy. Okay, and then this orbital would be having the highest energy, but I have just considered these orbitals. So among them, this is having the highest energy. Why? Because this is further away from the nucleus. This is further away from the nucleus. Okay, so this rule says that you have to fill 1s first. You have to fill 1s first. Why? Because it's having the lowest energy. Because it's having the lowest energy. Okay, let's suppose this is let's suppose this is Ali, and it's hungry since 7 a.m., let's suppose. And this is Ahmad, which is since yesterday. It means that he is having the lowest energy. Even he cannot walk. Even he cannot walk. He cannot move. He cannot tell. He cannot communicate. It's having the lowest energy. And it's having the medium, the moderate energy. So ultimately, when I would be having a container in which I have food, so basically I would be giving to this guy. I would be giving to this guy because I know that he is hungry since the yesterday. So obviously he is having a lower energy. So obviously I'm going to give the food container to this person. Okay. Same goes with the orbitals, with the subshells. Those subshells which are having the lowest energy, they would be filling first. So ultimately, you all know that 1s orbital is having the lowest energy, then 2s, then 2p, then 3s, then 3p, then 4s, then 3d, then 4p, then 4s, then 5s. So you can memorize this as school, school, public, school, public, school, doubt, public, school. You can memorize it. You can memorize it. School, school, public, school, public, school, doubt, public, school. Okay. So, and then let's suppose I have this chlorine. Let's suppose I
Sir,
have this chlorine. Yes.
so what is this principle called?
Aufbau principle. This is Aufbau principle, which says that we have to fill those orbitals which are having the lowest energy. So how can I decide which orbital is having the lowest energy? So I have drawn this table. With the help of this table, I can say that the 1s is having the lowest energy, and then 2s, then 2p, then 3s, then so on. So this table is helping us to decide that which orbital is having the highest energy and which orbital is having the lowest energy. And then let's suppose I have chlorine whose proton number is 17, whose proton number is 17, and you know that proton number is represented by Z. So you would be writing 1s2, 2s2, 2p6, 3s2, 3p5. Am I right? Is that correct configuration? Yes or no? Is that correct configuration? Yes, Iman, Amir, Hadia, Irtaza, Muhammad Umair. Is that correct? Tala, Zainab, Zaina. Yes?
Yes, sir.
Okay, good.
Yes, sir.
So basically, these are the subshells. These are the subshells. Okay. So let me draw this configuration in this manner. So this is 1s2, in which I have 2 electrons. This is 2s2. Again, I am having 2 electrons. Then I have 2p6, 2p4, 5, 6. Then I have 3s2, 1, 2, and then I have 3p5. Okay, 1, 2, 3, 4, then 5. So these boxes are going to represent the orbitals. These boxes are going to represent the orbitals. This is a clear configuration in which you can see you have an neutron. So obviously it's going to make a bond element so that it can pair up. It can pair it up. Okay. So this was first rule for electronic configuration. Okay. Then we have the second rule, that is called Pauli exclusion principle. Then we have the second rule called Pauli exclusion principle. Okay. Then we have the second rule. Then we have the second rule, which is called Pauli exclusion principle. Pauli exclusion principle. Pauli exclusion principle. This principle says, okay, that an orbital, let me tell you, you are supposed to write it down. This Pauli exclusion principle says that an orbital can occupy a maximum An orbital can occupy a maximum of 2 electrons, a maximum of 2 electrons, okay, which must be in opposite direction, which must be in opposite spin, or you can say direction. Okay, so basically I mean to say that if you can see over here, what I did basically, I am not supposed to write 2 electrons just like that. This is wrong. This is wrong. Okay, I am not supposed to put 2 electrons just like that, having the same spin. This is called with the same spin. When the both electrons are having the same spin, so they would be repelling each other. As a result, they would becoming unstable. They would becoming more unstable. Okay, atom should be stable. Any compound should be stable. Okay, so we have different criteria for the solubility. One of them is that Pauli exclusion principle says when you are going to put electrons in different orbitals, so you have to, or you are supposed to put electrons in an orbital in such a way that the electrons can have opposite spin. The electrons must have opposite spin so that their repulsion can be minimized. So upward, downward, 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 then upward. If you have single electrons, so that would be upward. Okay. If you have single electrons, so then you would be writing it down. Like you can say you would be putting in an upward manner. So this is called Pauli. This is called the Pauli exclusion principle. And then we have the third rule. Okay. Then we have the third rule, which is Hund's rule. Which is what? Hund's rule. Which is Hund's rule. This rule says, okay, like orbitals are filled. Orbitals are filled singly first, okay, and then double it. And then pair it up. What does it mean? Let's suppose you have 3p5. No, let's suppose you have 3p4. You have 3p4, and you know that p subshell is having 3 boxes. I mean to say that p subshell is having 3 orbitals. Okay, this is the first electron, this is the second electron, this is the third electron. Am I right? Is there any mistake? Is there any mistake in this?
सर जो आखिरी सबशेल में एरो था वो ऊपर की तरफ
Good, exactly, ऐसा ही है. So first of all, मुझे इसको क्या करना चाहिए? Upward. When you are going to fill it singly, so you are supposed to put electrons in an upward manner. And then I have 4, so I would be then double it. I would be doubling it. Those who are thinking that we can also fill this you can say orbital in this manner, they are wrong. This is wrong, this is right. Because Hund's rule says that if you are going to fill orbitals, so you are supposed to fill singly, single, and then if you have 4 electrons, obviously more than 3, then you would be pairing it up. Now it's your compulsion. But individually, if you have different subshells and you are going to put electrons in different orbitals, so obviously you are supposed to fill it singly. And then if you have filled it singly, then you are supposed to fill it double. This is the Hund's rule. But why? Let's suppose you are going to fill singly, just like that. Obviously, when you are going to have single electrons in an orbital, so there would be no repulsion. There would be no repulsion. But if you are going to put 2 electrons in the same orbital, obviously electrons have a negative charge. So there is a chances to have a repulsion between these 2 electrons. That is called spin pair repulsion. That is called spin pair repulsion. So to avoid this spin pair repulsion as much as possible, so Hund's rule says that you are supposed to fill electrons in different orbitals in a single manner, and then you can double it. And then you can double it. Let's suppose I have sulfur. Let's suppose I have sulfur whose proton number is 16. That is 1s2, 2s2, 2p6, 3s2 and 3p. And 3p what? The proton number is 16. And 3p what? 12, and then 12 plus 4. This is 3p4. Obviously, if we are going to draw the 3p orbital, so ultimately this would be just like that. 1, 2, 3, 4. First, I have singly filled, and then I have doubled it. And then I have doubled it. Okay? Then, so these are some rules for filling electrons. These are some rules for filling electrons. Okay? So, yes. Now, can you please write down electronic configuration of phosphorus, then chlorine, then argon, then magnesium, then carbon. Okay? And then scandium. Then we have, no, I'm not supposed to write down the charge first. Then I have chromium, then I have copper, and then zinc. Can you write down electronic configuration, but fast? But fast. You can see the periodic table and just look at the proton number. Okay, I'm drawing this. You are supposed to match. This is 15, this is 17, this is 18, this is 12, this is 6, this is 21, this is 24, this is 29, and this is 30. So phosphorus would be 1s2, 2s2, 2p6, 2p6. So 2p6, then 3s2, then 3p3. Same thing for hmm, same thing for there is no sulfur. Okay, no problem. So chlorine would be 1s2, 2s2, 2p6, 3s2, 3p5. And then this would be 1s2, 2s2, 2p6, 3s2, 3p6. That is 18. That is what? 18, right? This is so much easy. This is so much easy configuration. Then the chromium is again 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d4. Okay, and then this is zinc. This is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10. This is scandium. That would be 4s2, 3d1. The rest of the thing would remain the same. Okay, the carbon is 1s2, 2s2, 2p2. 1s2, 2s2, 2p2. Okay, so these are electronic configuration. Then copper, 3s2, 3p6, 4s2, 3d9. This is the configuration for copper. This is the configuration for copper. Okay, it's very easy, it's very simple, right? Okay, and then I would be discussing some exceptional cases later on. We have some exceptional cases. Okay, like we have different orbitals, like you can say different conditions for the stability of orbitals. Some orbitals are unstable and some orbitals are stable. So like you must know that which orbitals are less stable and which orbitals are more stable. You need to know. You need to know which orbitals are less stable and which orbitals are more. Okay. So, those orbitals which are half filled, those orbitals which are half filled, those orbitals which are half filled, they are more stable. Okay. So, stability criteria. So, we have different conditions for the stability. Okay. Fulfilled and half filled. Fulfilled and half filled. Both are stable. Both are stable, but fulfilled is more stable than the half filled. Okay, and then partially filled is unstable. What is mean by the term partially filled? Let's suppose you have s orbital. If you have s2 and if you have s1, so I can say that this is fulfilled and this is half filled. Both conditions are stable. And let's suppose if you have P3 and P6, again, same thing, I can tell you that, again, the same thing. Again, the same thing. Both are stable. But if you have P1, P2, P4, and P5, these are called partially filled. Which are unstable. Which are unstable. Okay. And what about the d orbital, the d subshell? Let's suppose if you have d10 and d5. Let's suppose if you have d10 and d5. This is full filled, this is half filled. So these are more stable. But if you have rather than this d1, d2, d3, and then d4, and then d6, then d7, then d8, then d9, ultimately I can say that they are partially filled and partially filled are less stable. Okay, so now we are supposed to apply this concept on the chromium. If you can see this, this is the chromium whose proton number is 24. So what did you write? 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d4. As you know that this is 3d4, as you know that this is 3d4, which means that this d orbital is partially filled. This d orbital is partially filled, which is unstable. Which is what? Which is unstable. So to make it stable, this 4s orbital is going to give one electron to this 3d4 orbital. So after gaining one electron, okay, after gaining one electron, it would be coming just like this. It would be coming just like this. So after gaining one electron, it becomes half filled. It becomes half filled, which means this is the more stable condition as compared to this guy. This was 3d4, which means that this is neither fulfilled nor half filled. This is the partially filled, which means that this is unstable. So after giving one electron to this 3d, 4s also has only one electron, which means that this is also half filled condition. So those orbitals, those subshells which are half filled or full filled, so they are supposed to be more stable one. So if the examiner would be asking electronic configuration for chromium, so you are not supposed to write down this configuration, but you are supposed to write down this configuration, and this is important to know. Yes, are you all getting my point? Yes or no?
Yes.
All correct. Okay, good. Nice. Nice. Okay, so this is all about electronic configuration, right? And then we have different practice materials. Then I would be telling you that you must write electronic configuration for copper. You must write electronic configuration for copper. In short, you all are supposed to write down electronic configuration for hydrogen to zinc. Write down configuration for hydrogen to zinc. Right? Okay.